Okay, I don't know. I'm in the middle of the lesson. Okay, section 2.6, combinations of functions and composite functions. So first of all, we need to make sure we can find the domain of a function. So I'm not going to read this to you. I'm going to tell you what's important, is that we have domain issues in these cases only. So when you're looking at an equation, the first thing you're going to ask yourself to find the domain is, do I have one of the two issues? There's a third issue, but we haven't learned logs yet in this class, so we're not discussing the domain issues that logs create. So the only two domain issues that we're going to have to deal with are when you have division by 0 or take the square root of a negative. Those are the two things you have to look for. So if I ask you to find the domain of a function, if you look at the function like number 1 and you're like, that doesn't have a denominator and it doesn't have a square root or a fourth root and an even root, then you can just say that you know the domain has to be all real numbers, because the two issues are not there. All right, if you look at number 2, then you realize that there's a denominator, so I can't have 0 in the denominator. So to figure out what the problem is going to be, you set that equal to 0. You're saying that we can't do that. So x squared can't be 49, which means x cannot be positive or negative 7. So the easiest way to write your domain this way is if you do set builder and you say you want x is such that x is not negative 7 or positive 7. If you don't like set builder, you can write it in interval and to say go up to 7, negative 7, and then pick back up on the other side and go to 7, and then pick back up on the other side and go to infinity. Like, that's a lot of things to write. So it's easier to just write it in set builder when you're just skipping a couple of numbers. Okay, for a square root, we are saying that we want what's underneath the square root to be 0 or bigger. So we're going to say greater than or equal to 0. So then you just solve that, and that's your domain. It has to be greater than or equal to 0. So again, if you are okay with set builder, it's pretty easy because you can say the domain is the set of x's such that x is greater than or equal to 3. If you hate that and you'd rather write it as the domain is 3 to infinity, you can do that if you like the normal notation better. Alright, so again, if it has a variable in the denominator or under a square root or a fourth root or any even root, that's when you're going to have a domain issue. Everything else that's given to you, no matter how weird it looks, is not going to have a domain issue. It'll be negative infinity to infinity. Okay, so the next thing is, can we combine functions? Alright, so we have the sum of two functions, which can be written either way. The difference can be written like either one of these. Product can be written like either one of these. Quotient can be written like either one of these, but you have to keep in mind that when you create a denominator, you gotta give me that domain restriction. Alright, so we gave you two functions. I want to know what is f plus g, what is f minus g, what is f times g, what is f divided by g. Alright, so remember that f plus g of x is just f of x plus g of x. So all we're doing is combining any like terms that we have, and we're done. Okay, same thing with subtraction. You're going to take f of x, subtract g of x. So remember that that minus gets distributed, and then combine any like terms that you have. Alright, so the next one, we're saying take f of x and times g of x. So that's just a distribute. So x to the third minus x minus 5x squared plus 5. And we like for things to be in standard form. So just rearranging my terms and I'm done. The good news about division is that it's just take one function and write it over the other one. But you have to stop and say, I know I created a domain problem. X is not allowed to be 1 or negative 1 because that's going to make this denominator 0, and that's a problem. So this is the work to get that domain restriction. All right, so one more of those. So pause and try it and see how you do. All right, so x plus 2 plus x squared minus 3. So x squared plus x minus 1. X plus 2 minus x squared minus 3. Would give us negative x squared plus x plus 5. X plus 2 times x squared minus 3. So x to the third minus 3x plus 2x squared minus 6. So for division, it'd be x plus 2 over x squared minus 3 with the statement that you know we can't be plus or minus the square root of 3. And again, that's take the denominator, equal it to 0, and solve. And that is where that comes from. Okay, so what if I give you something that's not polynomials? All right, well, if I ask you to add two crazy looking things, usually you can't. So you're just going to say that's the answer. Okay, so can you tell me the domain of f plus g? Well, you have 2 square roots, so this is where the fun stuff comes in. So for this one, we need numbers that are greater than or equal to 3. For this one, we need a number that are greater than or equal to negative 1. Well, if we put them together, we've got to make both of those happy. So this is going to have to be like an and statement. I've got to be this and this. So, I just said this and pointed like you could see it, sorry. I need to be greater than 3 and greater than negative 1. So to be greater than both of those numbers, I got to be greater than the bigger one. So this is the most restrictive. If you think about a number line, negative 1's here, 3's here. If I'm saying this and this, then I've got to be where both of them are. So the domain would be x such that x is greater than or equal to 3. All right, so composition of functions. Read this, like pause and read it. All right, so basically it's saying that for the domain of a composition, you have to be in the domain of the first one and then in the domain of the new thing. So basically the domain of the new thing is all you really have to worry about. So do the composition, look at what you get, tell me the domain, don't overthink it. All right, so composition of functions, to start with, we're just going to, can you do the composition and evaluate it at a value? All right, and I'm going to show you 2 ways to evaluate, because if they don't ask you to do this first, you can evaluate this without doing this. All right, so there's no way I'm going to fit all of this, so we're going to do A down here. So f of g, I prefer to write it like this instead of that little fog notation. All right, so this is literally saying plug g into f. So I'm going to write the f function down with parentheses where the x is, and I'm going to use g to plug the hole. All right, then I'm going to do a little bit of cleanup, so distribute and combine like terms. All right, and then part C, if I already have this done, then part C is as simple as, can I plug negative 1 into that? And get an answer. So what is this? Negative 1 squared is 1, times 10 is 10. This becomes plus 5, plus 1. So this is equal to 16. All right, so let's do D, and then I'll show you on D how you can do that evaluating without actually knowing what g of f or f of g is. All right, so this wants me to do g of f. So plug f into g. And I found the easiest way for most people is if you write down the g function with parentheses, anywhere there's an x, and then you plug your holes with the f function. All right, so I'm going to come over here. 5x plus 6 squared is 5x plus 6 times 5x plus 6. All right, I'm not going to write everything down, so make sure you're listening. This is 25x squared. Well, when I multiply the outsides, I get 30x. When I multiply the insides, I get another 30x. So that's 60x. And then when I multiply the ends, I get 36. So this is 2 times 25x squared plus 60x plus 36. And then minus 5x minus 6 minus 1. So now distributing the 2. And I added negative 6 and negative 1. Now combining like terms. And this is the answer for g of f of x. Okay, so now, if I want to do this, and let's say I haven't figured out this over here yet, but they just asked me this question and gave me those two functions, I can work from the inside out. So if I find g of 2, so come over here and plug in 2. 2 squared is 4 times 2 is 8. Minus 2 is 6. Minus 1 is 5. So I know g of 2 is 5. So let me erase a whole bunch of stuff real fast, Joe. Okay, so this is f of g of 2. And I'm working out. I said g of 2 is 5. So replace that, now I'm just finding f of 5. So go to your f function, 5 times 5 is 25, plus 6 is, what, 11? Okay, now let's see if I can put all of that back so it's there when I do the notes. Good job. Okay. I'm going to write that in a different color. Or not. Alright, so just to recap what I just did so that I can write it down. If I write this like this, we plug the 2 into g of x, and we got 4, 8, 6, 5. And then we plug 5 into here, and we got 25 plus 6, so 31. Alright. Alright, so this one I want you to pause and try, and then check and see how you did. Alright, so for A, we have f of g. So 3 times x squared minus 2x plus 1. So 3x squared minus 6x plus 3. If we do B, we're doing g of f. So we're going to do 3x squared minus 2 times 3x plus 1. So that's 9x squared, so I squared 3 on the x, minus 6x plus 1. Alright, so C, we're going to use the fact that we know this. So we're going to say 3 times negative 1 squared, minus 6 times negative 1 plus 3. So 3 plus 6 plus 3. So ultimately we get 12. No, really, I went perfect. Thanks. Okay. so this one we'll try the other way. We do f of g of 2. So g of 2 is 4 minus 4, so 0, 1. So f of 1 is 30. Alright, so when you're doing the domain of a composition, you have to take out any x not in the domain of G, and then any x not in the domain of f of G, which then all works itself out when you just look at what you've been given. So for f of G of x, we're going to do four over, and then 1 over x plus 2. Alright, so we know that x cannot be 0 because of this itty bitty fraction. So because of just this little bitty fraction right here, we know x cannot be 0. Alright, well, because of the entire denominator also cannot be 0. So I'm just going to say let's logically think about this. This needs to be negative 2. So if x is negative 1/2, that's going to work out. Okay, so if that made like no sense to you, subtract the 2. Then you got to multiply by the x. So I said do it, and then I didn't. So 1 is going to equal to negative 2x, and then divide by the negative 2, and you'll get it. But if you think about this, you have 1 divided by something needs to be negative 2. Well, if this was 1/2, that when you divide, you multiply by the reciprocal. So that would be a times 2. So this would end up being negative 2 plus 2 is 0. But either way, you have that x can't be 0, and you have that x can't be negative 1/2. So those make up your domain. X is such that x is not 0 or negative 1/2. All right. If you have questions, email me. Do your assignment, take a picture, and email that to me.